Hi everyone, and welcome back to Physics with Mr. Simons, where we make physics simple and get you exam ready. Again, we're looking at Newton's laws, right? In today's problem, we're looking at a single body that's pulled at an angle, but that angle is not given to you, so along the line we're going to ask you to calculate the size of the angle by giving you the other items. So this is a variation from the first video that I've just done. That's just to show you how you can end up studying the same thing, but if you don't understand how we can change a question, we still catch you out in exam. But you're not going to fall for that because I'm going to make sure you are prepared from all angles, right? So let's look at the problem. So a 12 kg object is pulled towards the east with applied force of 70 newtons. So we have applied force of 70 newtons. Right, in the drawing, they've given me a force of friction, that's 20 newtons, so there they don't want me to calculate, but then I have to use this to calculate something else. Right, and there as you can see, the angle is just labeled as beta, right, pulling a 12 kg. So number one, can we draw a free body diagram showing all forces acting on a 12 kg object? So normally when my examiners feel free, they would give you 3 to 4 marks just drawing a free body diagram. So we need to understand what forces are acting on that object. Now, number two, determine the magnitude of the normal force as well as the force in the y direction, or also sometimes called my perpendicular force. Given that mu k equals 0.34 for 5 marks. Then we want the size of angle beta, and as you can see, it's only 2 marks. So therefore, that means I'm going to use whatever I got in number 2 to get the 2 marks for beta, and then without fail, if I'm working with Newton's second law, we will always ask the acceleration of the block. So when you see that, we are working with F net equal to ma. So that's 5, 10, 12, 16 marks, one small exam question. All right, so pause the video, try to attempt to answer as many of these, see where you have gone wrong as you work through it me as I'm solving on finding the solutions to these problems, right? So without further ado, let's look at the free body diagram. So draw a free body diagram showing all forces acting on a 12 kg object. So number one, I have applied force then of 70 newtons, right? The object is not moving up and it's not moving down, but we know force of gravity is pulling it down. Therefore, the force balancing it up there would generally be my normal force, right? There, friction, we always have for object to move while we are pulling it, we require friction. So therefore, friction to the left, and looks the same as the previous one, 4 marks, or can go FAX, right? My force applied in the X direction, force applied in the Y direction, normal force, and I have my friction and my force of gravity. So very important, once you see something being pulled at an angle, we are changing the fact that normal force equals force of gravity. We actually need to know that normal force plus my force in the y direction must equal my force of gravity. So you can see I'm doing a second problem, and there's a pattern you want to see. This over and over where you catch learners out with the applied force in the y direction. FAX minus F should give me my mass times acceleration. Right, so that is my first basic 4 marks. Right, now let's go to the first problem. Determine the magnitude of my normal force and my force applied in the y direction, or force perpendicular, if mu k equals 0.34. So we've given you force of friction. You know it's 20 newtons. Equation for force of friction, F equal mu k times Fn. Right, so friction is 20. Mu k was given as 0.34. So 20 divided by 0.34 should give me my normal force. Right, and if I divide that, I get 58.8235 newtons as my normal force. Right, now to get my force in the y direction, I first need to understand that there's no movement in the y direction. So my net forces in the y direction must equal 0. Right, nothing's moving up or down. So my normal force plus my force applied in the y direction must equal my force of gravity. Force of gravity is simply 12 times 9,8, or mass times gravity, minus my applied force or my normal force, which is 58,8235. If I subtract that 2, I get 58,7765 newtons. So that's my applied force in the y direction. So 1 mark there for correct substitution in the friction equation. 1 mark for the normal force. 1 mark for understanding that my net forces in the y direction is balanced, is equal to 0, no movement. Right, so normal force plus force applied in y direction equal force of gravity. And then from there, taking normal force across. So my force of gravity minus the normal force we got. Give me that answer. That is your 5th mark. So there is 5 marks given to you. And you're going to have to get used to this pattern. You see, this is the second video where I'm using this concept. It's not the last time you're going to see it. You're going to see it over and over. So pause if you must. Get used to this concept. As soon as we pull something in an angle, we'll always have a y component with the normal force to equal force of gravity. Right, next problem. Determine the magnitude or the size of angle beta. Right, so number 1, I've now solved in the previous problem that the applied force in the y direction is 58,7765 newtons. So from our previous video, I've explained to you that my force in the y direction would always be y sin. So Fay would always be applied force times the sine of beta. Right, meaning from beta, I'm going to opposite because y is going up over hypotenuse. Opposite over hypotenuse gives me sine. 58,7765. Applied force was 70, so there I substitute 70. So get sine beta on its own. I make that the subject to the formula. That would become 58,7765 divided by 70. Right? Shift sign. Now calculator. Punch in 58,7765 over 70 equal, and we get beta equal to 57,1047 degrees, or we round off 57,110 degrees. 1 mark. Please, the degrees sign, very important. I'm calculating an angle. 57,10 and 57,10 degrees are two totally different things. Right, so 1 mark there for understanding that 70 sine beta equal 58,7765, and then another mark there for getting 57,10 degrees. Right. Now let's look at the Newton's second law problem, which you normally end with. Determine the acceleration of the blocks. So there, you can say choose east as positive, you can say choose right as positive. Again, to get x, x is always cos, so Fax equal Fa cos theta. Applied force was 70 newtons, cos, the angle I got was 57,10 degrees. If I punch that in, I get my applied force in the x direction as 38,0147 newtons. So 1 mark for correct substitution, another mark for getting 38,0147 newtons. Right, now, they want acceleration, so my net forces in the x direction would equal my mass times acceleration, Newton's second law. So that gives me applied force in the x direction minus the friction must equal my mass times acceleration. So another mark there for understanding which forces work in the x direction. Fax was 38,0147 newtons. Friction was given as 20 newtons. If we subtract that 2, I get 18,0174. My mass is 12, so that's 12. 18,0174 divided by 12 gives me 1,50 meters per second squared. So there I have my acceleration. So that is 1 mark there for correct substitution and 1 mark for the final answer. And as you can see, that one question, 6 marks. All right. So I hope you understand. I hope you see the patterns I'm trying to point out to you, like especially with X and Y. Because as we go to the more complex problems, as I say, we're taking it from easy to difficult, but at the same time ensuring that you see the different variations of these questions so that if you have to calculate the angle, etc. an exam, it's not a surprise to you, right? I know you're studying from textbook sometimes, and I know sometimes you work very hard practicing 10 different exam questions, but sometimes you practice 10 of the same problems and you don't see the variations and you still get caught out. But we will ensure that that doesn't happen. I wish you nothing but the best. God bless. Bye.